All right.
Yep. Okay, so we're going to go over this. Stop worrying about the mirror now, guys. Okay. If you did not get this right in 4 minutes, that means you need more practice. I can make up more of these, but you want to get the quick way down for multiple choice, and I guarantee you'll see stuff like this on the multiple choice tests and quests that we take. I'm going to add some stuff here to the picture. Force of weight here goes down in block 1. Force of weight 2 here. I'm going to put the tension on here. However, the tension is what kind of force when I treat this as one combined system? Internal. Internal force. And if we have an internal force and we're summing up forces on this object, the internal forces all add up to what? 0. So we don't have to worry about them. Okay? And I'm going to do another quick sketch here. I'm going to call this direction positive. So that's along the rope. That's the direction of increasing x. If you call it the other way positive, you'll have different signs on things. Also, if we had friction, there'd be more stuff going on here, but I said neglect friction. So we're going to sum the forces along the rope equals, remember I'm treating both blocks as one giant thing. My system is block 1 and block 2. So what am I going to do to the masses? Add them up. So right away, I'm going to put m1 plus m2 times the acceleration of the system. I'm going to take care of that right there so we don't forget to do it. I'm also going to leave variables in here for a minute, and then we'll go back and substitute later. So how many forces are there along the rope? Well, for this first one, a little bit of a reminder, do some scratch work here and then erase it. Traditional old incline plane problem where you rotate the x-y axis is weight between the x and y axis. So there's some weight that goes down the incline and some weight that goes kind of into the incline like that. We remember that from our regular incline plane problems. Well now, which one of those components is along the rope? The force of weight in the x. So there's weight in the x going along the rope, but in the negative direction. So when I sum the forces here along the rope, I'll have negative weight of object 1 in the x, because that's along the rope. What about tension? Do I need to worry about tension? No. And I'll put it on here. I forgot to. Do I need to worry about normal force? No, because that's perpendicular to the rope. So negative weight 1 in the x. Now I'm putting x. I could put rope here if that made you feel better, but I'm trying to connect to our old problem, so remember how to calculate weight 1 in the x. So now we keep going along the rope till we get to our next object. Tension's an internal force. We don't have to worry about that. But weight 2, is that along the rope? Is it going in the positive or the negative direction? Positive. So plus weight 2 equals m1 plus m2 times a. And that's it from the physics standpoint. That's it from the physics standpoint. So before we go any further, questions on where this came from, or why it's negative, or where this came from, or why I'm adding up the masses? Yep, where at?
Where the half point x.
This?
Yeah.
Okay. So I'm going to show you that again. I'm going to draw. Here's an xy axis, rotated.
Okay.
Weight's going straight down. Weight always goes towards the center of the earth.
Yeah.
So it's between, on a regular incline plane problem, the x and y axis. So will it have components if it's between the x and the y axis? Yeah. It's not along the x or the y. So this is the weight. There's an x part to the weight going down the incline, and a y part to the weight going into the incline. But what's the rope along? The rope is along the incline. Do you see that?
Yeah.
The rope is in the same direction as the incline. So which one of these forces should go in our summation if we're talking about the direction of the rope? Weight in the x. That's the only one that is completely along there. Because weight in the y is perpendicular, and weight, well, that's something at an angle. You've got to break into its components to consider it.
Okay.
Better?
Yeah.
Okay. And it's negative because it's going down the incline.
Yeah.
And we called this direction positive. 100% good, or?
Yeah, good.
Okay. Anybody else on why this is negative, why we have this, or why we have this, or the combined mass? Well, at this point, we have to plug in numbers, or we could plug in numbers. I'm going to keep plugging in variables because this is a skill you need, especially this weekend. You're going to have some free response questions where you're supposed to derive expressions, and there won't be any numbers in there. So I'm going to keep going to show you how I would do that if I was trying to derive an expression for A, and then I'll stop before I get all the way there. So weight 1, we'd have negative m1 times g, and then which trig function are we going to use on incline plane problems for weights in what would normally be the x direction or along the rope? You just have to remember, sine. So negative m1g sine theta. I'll eventually prove to you why that's the case. If you had somebody else for physics, they may have already proved that. In AP Physics, it is almost always still just fine to remember. You don't have to prove it every time. But it's sine for weight in the x plus force of weight 2. This is the entire weight 2. So this would be m2g equals m1 plus m2 times a. And if I wanted to solve this for some general result for every setup that looks like this, just divide both sides by m1 over m2, and I'd have to derive an expression for acceleration in terms of the masses and the angle, the theta that was given. But we're going to actually plug in the numbers. M1 is 5 kilograms. Oh, and did I already take care of the sign when I summed my forces? Yes. So when I plug in this g, it's just the magnitude now. It's 9.8. Every once in a while, I'm probably going to still be in physics mode, and I'll throw a negative or something on there. Correct me, I'll give you some bonus, okay, if I ever forget to do that. If I forget that I've already accounted for the sine. And then sine of 25 degrees plus m2, which is 5 kilograms, times 9.8 meters per second squared equals, we got what, 7 kilograms? I already forgot, yeah. 7 kilograms times a, and then you can solve for the acceleration from there, and you should get negative 0.1, about negative 1.6 meters per second squared. Sometimes when these numbers, when it's not a close call like this, you'll be able to check to see if the direction makes sense. This is a close call. We're getting a real small acceleration. But before we take some more questions and stop recording, the negative up here, look at the negative and think about what that means. Negative for block 2. Which way does that mean block 2 is going? Accelerating, not going. Which way is it accelerating? Up. That means block 1's accelerating down. So if released from rest, block 2 would go up and block 1 would go down. Okay, so this is the only thing going on here. This is it. Block 2 is going to go accelerate up. Block 1 is going to accelerate down. What if they asked you for tension in this question? Would you then have to go back and sum the forces individually on one of these blocks? Yes? Which block will be the easiest this time around? Nope. Because block 1, you'd have to do tension minus a component of the weight. I would claim, you know what? It's about the same. Because do we already have the component of the weight in the x? Yes. I'd probably still do block 2 just because there's, I don't know, there's no components, right? It's just tension up, weight 2 down. But you have to be careful on the sign. If you go back and sum the forces on block 1 and call up positive, remember, which way was block 2 accelerating? Up. So you have to change the sign on this or stay consistent with your picture over here. And for block 2, call which way positive? Down. And then it would just be, you know, if down's positive, it'd be negative t plus weight 2 equals m times this. m2 times this. You could go further. Go ahead and stop recording, and then we'll take a few more questions. Tap the side.